supposed to talk about for loops, more about for loops, and lastly, instead, I'm going to talk about the stat. Last week's stat. Ooh, that's very bad. Oh, it doesn't work. I'll just keep the lights on. So I'm going to talk about last week's stat. Just work through it, and also talk about the test. So let's say you come to last week's start and you sit down and you read the tutorial. How on earth do you do this stuff? Even if you know how to write verbal declarations and how to write verbal assignments, how to write if statements and while loops, for loops even, how do you go about solving all this? And I should have warned you beforehand, I'll warn you now, that this happens every single year. So many students, some of you came to our program, and that's hunky-dory, and I'm really happy about that. I'm a little scared that you're bored at the moment, but hopefully that will change soon. But the rest of you can't, and the same thing happens every single year, that students keep up with the course, and then they get to the first problem they really have to solve by themselves, and they just don't know where to start. Now, the idea of some of the problem solving we did in the first 2 weeks was supposed to get over that, but I don't think it went very well. I wouldn't trust you to solve advanced engineering problems for NASA or anything like that. Part of it is the fact that maybe those first slides need refinement, even though we've used them a couple of years, other courses. But I don't know, I still personally believe that the only way to really learn to program and solve these kinds of problems is to solve these kinds of problems over and over and over and over. So let's work through this and try to learn how to solve these issues. We are going to have more tutorials like this, or see more problems like this, maybe even in tomorrow's test, and you are going to have to think your way out of it, think your way into a program. So the very first step is you must read what the problem is asking you to do. Even when I write programs, I don't often read carefully enough what I'm supposed to do. We all make that mistake. You read and you read what you think you want to read, and it's not what's actually written on page. So the very first step is to read extremely carefully. Imagine picking a random point in the square with the corner points -1 and -1 and +1 and +1. So there's a square. It's going around the origin. It's 2 by 2 from -1 to +1, -1 to +1. So 2 by 2 square. There's a circle inside. I'm going to pick a random point. This point can lie either inside or outside the circle of center point 0, 0 and radius 1. Okay, fine. So if I pick a point like that one, that's inside the circle. And if I pick a point that's up here in this corner, it'll be outside the circle, even though it's still inside the square. So we're all happy with that. We can do that. I can imagine that. What happens if we repeat this step thousands of times and count the number inside-outside points? So I'm going to do this over and over. Pick a point inside or outside. Pick a point inside or outside. Pick a point inside or outside. Thousands of times, it says. And then we count. Well, if you can imagine points falling onto this square. And if they fall inside the circle, they're red. If they fall outside the circle, they're blue. And let's say they're about the size of this little dot. Eventually, this whole circle will become covered with red dots. It will fall in all red. And the pieces on the side will fall in all blue because they're outside the circle. So basically, what I'll be measuring, what I'll be covering, is the whole area of the circle. It says, well, we get a fair estimate of the area inside the circle and the area outside the circle. Good. Oh, that makes sense. I don't want to measure the area exactly. Maybe I can't. For a circle, it's easy because we know the formula. But for a different kind of shape, it may be more complicated. And this is a good way of calculating areas, sampling points randomly, and then checking how many are inside the shape, how many are outside. That gives me an estimate of the size, the area, for any kind of shape. So now answer the following questions. What is the radius of the circle? I'll let Helen answer that question. Helen, what's the radius of the circle? 1. Okay, I believe that because it did say that at the start. I remember something about radius. Radius 1, good. Radius of the circle is 1. So what is the area of the circle? Helen? Is it 1? Is it 0? I would say it's 0. Because the circle is just a line around the outside. These lines are mathematical lines, so they're infinitely thin. So circle, you could say, has no area itself. And the disk formed by the circle, Helen, has an area of power. Okay? But let's not overanalyze. Whoever wrote this probably just as much as an idiot as you are. And they probably meant the disk. In retrospect, that idiot should have said disk. But never mind. Anyway. What is the area? So, Helen, what's the area? What's the formula for the area of a oh, no. Pi radius squared. Radius is 1, 1 squared is 1. So the area of this circle is pi. It's 3.1. Okay, that's brilliant. All right, that makes sense because the area is 3.14159. No. What's the little formula? 3.1412653. Let me think about this again. Comma, I sent a line saying chocolate to running calculators all the words. So it's 3.141 5926535. Excellent. If you want to know, there's the whole rest of the right. You moving to a different classroom. Just a different. Oh, bye. The nice trip. Right here. There's a whole rhyme. You can recite all the 5 digits if you want. You can't. No, you can't. Of course, they're infinite. But what's the world record? I don't know. It's something like 20,000 digits. That's been memorized and recited. Never mind. Okay, fine. That's pi. What is the length of the side of the square? I've already told you it's a 2 by 2 square, so that's 2. What's the area of the square? Oh yeah, I wanted to say that's 4. So that makes sense. The square area is 4. That's a little bigger than the circle, so the disks, which is 3.141. That makes still sense. Okay. What is the area outside the circle but inside the square? Oh, that's easy. It's 4 minus 3.141. Okay, so we can calculate all those numbers just in our heads. Now we know what the answer must be. Pi. And I can write a program that prints that. I can write a program that just prints pi. Because there's a mathematical constant, math.pi, and that's great. But what if I didn't have that constant? What if I wanted to calculate pi? What if I were 18th century mathematician who does not have a computer, and I want to calculate the value of pi? I would go to my lawn, out a circle inside a square, and throw balls at the circle and count how many balls land inside the circle, how many land outside. And if I do that enough times, I can get some kind of approximation for pi. That's quite accurate. So, and that's exactly what someone did in the 18th century. But I don't remember whom. Maybe it was earlier. Okay, let's call the number of random points that fall inside the circle K, and that means the area is about AK. We'll call the number of random points that fall outside the circle O, and the area outside the circle AO. Then we can use the equation K over O, so that ratio of those two counts, outside the circle, inside the circle, is roughly the same, if we have enough points, as the ratio of the area outside the circle and the area inside the circle. Since we already know those two, we can calculate pi. Write a program. Oh, now comes our part. Write a program that reads an integer from the command line. Oh, yeah, I could do that. This integer denotes the number of points our program has to pick. Aha. So if we say our program pi 1 million, we must pick 1 million points, pick 1 million random points, count them inside or outside the circle, and then calculate based on those ratios pi, the value of pi. Okay. Now I'm skipping words because that's bad. I should be really reading every single word. The program must print the value of pi that it calculates based on these points. Okay, good. When executed, your program must behave roughly as follows, as shown below, not as follows. I'm filling in my own words because I expect something to be written here, but that's wrong. Okay, so someone said at the prompt Java pi 10, and the program picked 10 points and calculated its approximation to pi, and it got 2.8, which we know is not very good. And then he tried 100 points, 3.2, 1,000 points, got us to 3.132, 10,000 points, still not even, still didn't have the second digit after the decimal point. And with 100,000, we got to 1.4, let's go with 3. But that's one mistake in 1,000. I mean, that's less than 1% of a mistake. So that's not too bad. So let's write that. First check if YouTube is still switched on. It is beautiful. We love you, YouTube. Okay. And at least Eclipse is working today. So I'll use Eclipse. You can use the command line. It's just that I suspect you all prefer Eclipse. So I want to write a program, and I can write it in my previous projects, but I'm just going to start a new one. How do I do that? Well, the instructions are in that first tat, so second tat, but I happen to know them. Come on, Eclipse, don't be slow. Okay, everything is big enough. I'm going to call my program pi, finish, creating project, setting build paths. Oh no, don't make that. Oh no, I hope that mistake goes away. Well, it's done something. Is it waiting for something? No, it's not. It's fine. Okay, are you done? Oh, here we go. Okay, in source, I'm going to make a new Eclipse class, which is that button. And I'm going to call this pi as well. And hopefully Eclipse will fill in the basics of the program for you. But some, okay? Rightio. And I know that all my programs use a main function, so I'm going to start by writing that. Oh man, is everything going to be this slow? Why? Maybe my program is just a little, my computer is just a little tired. It hasn't done Eclipse for a while, so it may be just loading files that it hasn't seen. Yes, Conrad?
So what does one do if Eclipse is that slow?
Well, what I do is I decide, is it going to be worthwhile to actually switch to the command line in this classroom because it'll save time, or do I stick to Eclipse because the students will get some value out of seeing me use Eclipse for a change? Show that I'm not anti-Eclipse. I don't hate Eclipse. I love Eclipse, but clearly it has some kind of issue. What does one do? I don't know. If one is the queen, one asks Philip, fix eclipse, or something like that. One does not know what one will do in such situations. One is not concerned. Okay, next one is going to think about writing one program. And man, I've already forgotten what I'm supposed to do. Eclipse has put it out of my mind. Write a program, Java, doing that, yes, that reads the integer from the. And I'm not going to write this whole program at once. I'm going to start easy, build things up. Doing all of this at once is just too much. So let's just read something from the command line. I'm going to call it n integer.parseInt. This is just formulaic stuff that I can look up. Save, run. Am I? Oh, well. Creating a type. I don't even know what a type hierarchy is. Why is it creating one? No console to display. Ooh, something is happening. It's running. It's just the speed it's running at. Is it prompting me to do something? No, it's not. Why is it so slow? I'll just quit it. I can't even do that. Okay. I'm going to try again. I'm going to go here and right-click. Okay, now I'm starting to feel that from the command line, this will go a little quicker. But let's stick with it just a little while. This is not what I wanted or expected. Finally. Okay. So it's actually crashing. It says Java stopped executing. It says executing exception. So we can thread main. That talks about an index out of bounds and 0. We know what this is because we've seen this before, because we've written multiple programs. In our own time, it's complaining that I didn't supply any command line arguments. So I'm going to fix that, doing it the usual way, the way I like doing it, which is to say, loads of ways to do this, but I like saying run configurations, pi, arguments, and that string prompt thing. And apply. And yeah, I'll run it, I don't mind. Okay, 10. My computer is amazingly slow. It's not usually this slow, so clearly it's not happy about something, but nothing else is running, so except for YouTube. Can't believe YouTube would stab me in the back like this. It's probably not. It's probably something else going on with Eclipse. I probably didn't fix it properly when I tried to fix it. Maybe I'll just switch a second. Done. Print it in 10. One of the old days, because you could be this one. And we actually made, I think people learned the program more quickly because you couldn't afford to run your program over and over and over. You had to write it correctly the very first time, if you can, as much as possible. Okay, fine. So let's just assume we're back in 1980, and this is the speed of our computer. So I've done this part. I've printed the number I've read from the command line, but it's not supposed to be printed. It's supposed to be the number of times I pick a random point. So what's really going on is that 10 times or n times, I have to pick a random point, and I have to count that point from inside or outside the circle, and then use those counts to calculate a value for pi. So n is really the number of times I have to repeat something. Now, I would prefer to do this without a for loop, because last week when you had to do this, I didn't know about for loops. But now you do, so you now know that I can write for int I is 0, while I is less than n, I plus plus. And that will actually repeat whatever I write now inside the for loop n times. This is a for loop, that's a little idiom for repeating something 10 times or n times. Not 10 times, n times. There's a little idiom that we need to learn in Java and, in fact, in many other languages as well. Okay. And what do I have to do? Oh, this is so difficult. Why do I have to do computer science? It's a horrible subject. I can't be bothered to write the actual code. So I'm just going to write in comments, pick a random point, count if it is inside or outside. Calculate some formula, don't know what, and display. So I can write little comment statements to myself as placeholders for pieces of code I still have to write. When I write code, this is exactly what I do. I write little comments to say, I have to do A, B, C, D. Let's start just with A. So picking a random point. Did you want to ask something? No? Okay, fine, good. Right. How do I pick a random point? What's your name? Next to you. Sam. Okay, short for Samantha or Samuel? Samuel. Sam. Okay, Sam. How do I pick a random point? Are you twins? Can I use math or random? Okay, how? Hang on, I don't want to play the chain. Sam, why don't you tell us? You struggle, but that's exactly what I need. I need someone who struggles, like teach you, and by extension, the whole class. Say again? It's actually slightly confused. What did you say? I can't hear what you have to speak up. You're watching a third, you're missing a third was right. No? I don't become very well. Third. Sorry, Sam, again? Okay, brilliant. That's exactly what I need. So whoever that is said that he wants to use math or random. How do we use math or random? Did you get able to read it? It's also in the book.
I was reading it, but I didn't understand.
Just reading understanding whatsoever. Okay, fine. Only Sam and I, because she's quite clearly close to a nervous breakdown, and I don't be held responsible. We need to pick a random point. Math.random does give us random points. Math.random. It's a function that's like sine, it's just got a different name called math.random, and that gives us a random value. In fact, it says here, it returns a double value with a positive sign, greater than or equal to 0.0. How can it be positive if it's 0? I don't like that explanation. 0 doesn't have a sign. And less than 1.0. Okay, fine. So this is going to send back something that's somewhere from 0.0 to just less than 1.0. But it's just floating about, Sam. It's just floating about. I can't just write that. That won't do anything. In fact, it doesn't even compile. Java puts a medium-sized red X next to it. I have to take the value and put it somewhere. So I have to put it in a box. I have to put it in a variable. So I'm going to write a variable. I'm going to say double. It did mention that it sent back a double value. Okay? I'm going to call that X. Okay, right. So I've got an X. It is going to contain the random value that I get from that of random. You follow, Sam? I want you to tell me as soon as you stop following what I'm saying. Do you understand English? Okay. I use simple sentences. You say when you don't understand. Good. You good. Java good. Sam versus double. It's like you keep on talking to you see your like a guide dog. I mean, like some people have such anxiety. You don't have such anxiety. Please say. Keep on chatting to us. Maybe that's why you don't follow. I would say, I would listen to the person in class. You're thinking. But please, I don't mind if you say to your person next to you, oh my God, look how brilliant this code is. But maybe concentrate on what I'm saying. Okay, don't miss anything at least. Gee, I've got to hurry up. Sam's having to go to the next class to chat to her friend there. Okay, right. Maths at random. Setting back some value from 0.0 to 1.0. It's random. It's like a dice. It's going to be a different value every single time. I'm taking that value and I'm putting it inside a box called x. I can do that because x, I've told Java, is a double. I've declared the variable x to be a double, and I'm also giving it a value. Oh man, issues. X is going to be from 0 to 1. So that'll be the it's from 0 to 1, x will only lie somewhere here. So that means I can never pick a point that lies on the left-hand side of the y-axis. X can't just lie from 0 to 1. It needs to be able to lie from -1 to 1. So how do I fix that? Well, I've got a brilliant idea. Let's just do that. Now, subtract another random after random, get my point. So if the first one returns 0, and the second one returns 1, I get 0 minus 1, which is -1. That's what I want. If the first one returns 1, and the second one returns 0, I get 1 minus 0, so that will be 1. So that's the right point. Your side, right point. Unfortunately, this is a bad idea because it's going to skew the points that I get. I'll get more points in the middle. X will be more. It won't be as often. I want to get points on the sides as often. So that means I'm going to overcount the area of the circle right in the middle. I think the circle has greater area there. It's like if I had a transparency of the circle and I showed it to you, and then I heated the transparency, it would start melting, the circle will actually enlarge. So the stone are value apart. You are confused. Great. Excellent. Someone said, look at this. Look at this. This is confusion. He's speaking up about it. He's being honest. Yes. Values is what? The values is what? So a point. The point is itself. Can the points be numbers? Okay. Thank you for bringing me back to reality. What the hell am I doing with doubles and this X thing if I'm supposed to be picking points? Well, there's a short sentence that I skipped, which I should have told you. And that is that instead of picking points, which I don't really know how to do, I can't really pick, what is a point? How do you pick a point? Instead of picking points, I'm going to pick x, y coordinates. So I'm going to pick an x coordinate somewhere, and pick a y coordinate somewhere, and together they'll give me the x, y coordinates of a point. Sam, do you follow? Not very committed, not convincing. That was more realistic. So I need to pick a point. I don't know exactly how, but every point has a coordinate, and every coordinate is a point. So by picking an x coordinate here, like 0.25, randomly, and picking a y coordinate randomly, I'm in effect picking a random point. Do you understand that? And I mean, sure. Because it's so easy to just say yes. I want to pick random points. Instead of going to pick random coordinates, they're really the same thing. So I'm picking my x, and we've already, I've told you, but not convinced you, that doing it this way is bad. I've got to subtract stuff like this. If I have two math.randoms, it's going to disrupt the distribution of points. I have to find a different way using only one math.random. And the way to do it is as follows. This math.random only sends back points in an interval of size 1. It sends back random points, but they all lie from 0 to 1. The interval that I'm interested in is actually from -1 to +1. So it's of size 2. So what I'm going to do is I'm going to take my math.random and simply multiply it by 2. So now it's sending back values that lie randomly from 0 to 1. And after I multiply it by 2, I get a value that lies randomly from 0 to +2. Sam, do you follow that? Oh, excellent. Oh, surprise. But now I have random points lying from here, there. I wish I could point with this thing, but you can see it's tied to the desk, and it doesn't have a laser pointer. And in my experience, laser pointer batteries last about 5 minutes. So that's why I don't have laser pointers. I'd love to have one, so I'm just going to kind of like want to show you that my x's now lie from 0 to +2 over here. So all I need to do is just to shift it back 1 unit so that they lie from -1 to +1. So every single one of these x's, I'm going to subtract 1. Math.random sends me something that lies from 0 to +1. I multiply by 2, and I get something that lies from 0 to +2. And I subtract 1, so I get something that lies from -1 to +1. If you do not understand this, I am not going to explain it now. But I'm going to tell you that you must go home, when home is equal to Nachal, and write little programs that will print 100 values of math.random, 100 values of 2 times math.random, 100 values of 2 times math.random -1. And you will see. Okay, so I'm going to delete that comment because it's no longer accurate. And I'm going to quickly pick a y as well. I'm picking an x -1 to +1. I'm picking a y -1 to +1. So now I actually have a point. I have x and y coordinates for my point, which lies somewhere in the square. From -1, -1, +1, +1. I've got a point in the square. Now I've got to count if it's inside or outside the circle. I'm going to count the points. So I'm going to keep track of how many lie inside and how many lie outside. I have to store those counts somewhere. I have to keep a record. So I will need variables to help me with the count. So what I'm going to say is I'm going to say int inside. Well, right at the start I have 0. Int outside, right at the start I have 0 of those. So I've got my 2 counters. They're going to count how many inside, how many outside. I'm going to repeat n times, picking a point. If xy is inside circle, I'm going to say inside comes inside +1. I like writing it like that. I'll tell you in a second. And outside becomes outside +1. So every time this for loop repeats, it's going to pick a point, check if it's inside or not, and update right count. Yes, you were going to say something.
Why didn't you just call it inside and outside when you told you to call it?
Oh, you can. Why not? Well, I could have. But the truth of the matter is that in 5 years' time, when I look at this again, I won't have access to some of it. I may still keep my code in my first year, and then inside and outside is going to make a lot more sense than going, oh. But this program is so short that calling it K and O and writing a nice comment would have been fine. Let's do that. Let's say that I want to say that this is number of random points inside the circle. But now I want to rename it. So I'm just going to right-click on there, refactor, rename. Okay, enter. And it is actually renamed inside everywhere. And I can do the same thing with outside. I hate calling variables O because it looks so much like a 0. Now I'm really sorry I did that. So I think I'll just reverse that. But changing your mind about the names of variables is not difficult in Eclipse. It allows you to actually rename all the variables. But inside and outside because it's a little clearer. And it doesn't cost anything. Okay, fine. The only thing that remains is to say, is this inside the circle or not? How do we check if something is inside the circle? Ooh, maybe difficult. Let's just see. Circle has radius 1. So all the points here right on the boundary, they're distance 1 from the center. And all the points inside the circle are closer to the center. So their distance from the center is less than 1. And all the points outside the circle, over here, they're further from the center. Their distance to the center is more than 1. So I can really, if I can calculate the distance, if distance of x and y is greater than 1, no, less than 1, or equal, let's say the boundary is also in the circle. If that distance is less than or equal to 1, I know that the point is very close to the center. So I'm going to say inside. If it's more than 1, I'm going to say outside. And all that needs that remains is to calculate the distance. So I just assumed that you all know how to calculate distance because it's something so basic. And of course, we all know how to calculate distance. So Google Maps, type in the first address, type in the second address, will tell you the distance. But in mathematics, we can't do that, obviously. So how do you calculate distance? Well, it's the square root of a minus a squared, I write it like that, plus b a minus c squared plus b minus d squared. And that's a distance from AB to CD. But now I suspect many people did not know this formula. So who knew this formula? Okay, who did not? Sam, did you not? Remember if you remember the formula. Say again? The format. Okay, I'll change the format. It's the square root of that times a minus c. You know the Sam? Very reluctant to admit any awareness of facts. Yes.
Why aren't you using just a squared plus b squared equals 30 squared?
Maybe my mistake confused Sam. Why am I not using a plus b squared? Well, this is more general, so it's a distance between any 2 points. And definitely, if point CD is 0, 0, the center, then this formula will change. If C is 0, then this becomes A, C is 0, so that's A times A. And B is also 0, so that becomes B times B. That's definitely the formula that I'm going to use now here, because CD is 0. I want to calculate the distance from 0 to origin to my random point that I've chosen. But in general, if you have 2 points, AB and CD, then it's this formula we use. Sam, worth remembering, but you already knew, so it's no use telling you now that you need to remember it. You already knew this. That's amazing and very good news. So distance is this formula. I'll just copy it. And of course, it doesn't know B and A because I've actually used X and Y. It doesn't know square root because in Java that's called math. That's square root if you're using blocks, or math got square root if you're not using blocks. If you're using blocks, math got square root, math got sine, right. Then it says all the things we can do in math. Okay, and the only thing that remains is to calculate that final formula at the end. So I'm going to go a little bit quicker because we're running out of time and I still want to tell you about the test. So, right at the end, we're supposed to print pi. I'll just write the formula, not a fancy string in front of it. So let's see. The ratio of circle area to square area, we know, is pi, that's a circle, divided by 4. And that is equal to, that area should be equal to our sample. So our sample equivalent for the inside of the circle is inside. Our sample for the whole square is not outside. It's outside plus inside. The area of the whole square inside plus outside, inside plus outside. So if I take this formula and I manipulate it a little bit, that's supposed to be pi, then I get, if I multiply both sides by 4, I get pi is equal to 4 times inside divided by inside plus outside. So I am going to leave out that. I just did a little maths in Eclipse, but never mind that. And I think that'll work. Save it. Let's run it. Let's try 1,000 because it seems 10 is going to not be a. Okay, now of course it needs to run 3. Oh, bad approximation. Let's run again. Let's run it 100,000 times. 100,000. Okay. Damn. So people saying 333 that's just interesting. But of course, I can't expect Java to know that I want to double Sam. What does your mom say? Oh, sorry. No, I'm mistaken. I can't expect Java to know that I want a double value. I've taken 4, which is an integer. I've multiplied it by inside, which is an integer. Then I've divided by that sum, which is also an integer. All I've done is integer division and multiplication. Java had no clue that I wanted to double. So I'm going to help it along by just writing 4.0. Let's see if it works. 100,000. And that's value. Let's just do 1,000,000 while we're at it. And then we stop. Oh, still not very good. Probably have to go further. There are actually better ways to calculate pi using approximation. That does not count random points. Okay. So let's talk about the test very, very quickly. You're writing a test tomorrow. Hang on, people are taking pictures of the screen, so I will help them by just showing them all of the program. There you go. Right, you're writing the test tomorrow. It will be in our class. It will be 1 whole hour. You must come early, please. We will guarantee that you have a seat when you arrive, short after you arrive. You will have the full time. The test itself will contain 4 questions about variable declarations, variable assignments. Can you write those? I want to check that. And loops. Can you write a simple while loop? Can you write a simple for loop? It's not supposed to catch you out at all. It's measuring if you're up to date. I cannot give you samples of last year's test because last year we didn't have 3 weeks at the start where we did problem solving and automata. So last year we were much further ahead. And so if I gave you last year's test, you won't be able to do, some of you won't be able to do any of it because it just covers more material than we did this year. But I will put a sample test online by 1 o'clock. Okay? I have an appointment now with other people until 1 o'clock, then I'll put it online. And one last thing is that you must come and write the test in our class. Test schedule. Who comes early, who comes late? We're writing in 2 groups again. Right. I'll see you tomorrow.